Dr. C here. Just to let you know, you're lucky that you're sitting at home with your warm blanket because it is freezing. That's why I have like 40 jackets on. Okay, so I went ahead and I just took our chromatography paper out and I laid it down because we want to let it sit for a little bit because this solvent line will continue to move. But it's been sitting for a while, and so I feel pretty good that it's not gonna move any further. So now we're gonna process our chromatography paper. So what we need to do is we need to draw what's called a solvent front. Because if I let this sit too long, I won't know where the line stopped. Where did my solvent stop? So literally you just trace the line. So let me put my finger on the paper. So you just trace exactly where the solvent stopped. So that's called our solvent front. Sometimes if you process your chromatography paper quickly, then you don't really necessarily have to draw the line because you did it really quick. So now what we want to do is we want to be able to compare. Now you can kind of do a visual comparison, seeing like here's our B1 and our Y6. You could kind of see visually them. But the goal is to figure out what is in our unknown. Okay? You have 3 different colors, 3 different dyes, and each of these unknowns. So that's kind of what we're doing. So one thing you could do is you could do a qualitative. You could kind of look at it and kind of see like, okay, which one do you think that one is? So that kind of thing. But we also want to do quantitative measurements. So if we look at our data table, we're going to try to do a quantitative measurement. So in our data table here, if we go to the bottom, I want to point out one thing with our unknowns. Since we're doing 2, you want to go ahead and add that in there. And then also, remember we're not doing our B2, so you can just scratch that out, okay? But we have 3 unknowns in each of these. So just kind of elongate your table however you want. But so what we want to do is we want to calculate what's called a retention factor. So RF is our retention factor. And so to calculate the retention factor, it's the distance of the spot traveled divided by the distance the solvent traveled. So we got to get these 2 measurements. We got to get the distance the spot traveled and the distance the solvent traveled and divide them to get our retention factors. So the retention factor is going to tell you how much did it stay at that starting point line compared to how much did it move. So a high retention factor, it meant it moved a lot. So like a retention factor of 1 meant it went all the way up the paper, and a low one meant it stayed. And so this is a good way for us to figure out what is our unknowns. We can look at what our retention factors and our unknowns are and compare them to our known dyes, and that's a quantitative way of figuring out what we actually have, okay? Now, another thing I want to mention is that we're doing them in both salt and the isopropyl alcohol. And so sometimes when you're doing this, you might be like, ooh, you're late for class. Sometimes you might be doing this and you're like, I don't know which red it is. Because maybe one of them, the retention factors weren't as clear. And so you would look at both. So when you're trying to figure out what your unknowns are, we want to look at both of our mobile phases, both of our salt solution and our isopropyl alcohol to figure out what our unknowns are, because that's the big goal of today's lab. All right, so let's start filling in this table, okay? So the first thing you have to do is you need to line this up. So remember, we spotted it right at that hash mark. So I want to take my ruler and I want to line it up so that it's right on the hash mark, okay? So right here on the hash mark is where my ruler is at. So the first thing we're going to calculate in our table is D spot, okay? And so what we want to do is we want to measure the D spot you want to be consistent. Some people like to measure it at the top of the spot. Some people like to do it in the middle of the spot. You pick where you want to measure the spot based on the top or the middle, and then pick that. So you need to write your distance. So if you pick the top, you measure out the distance and you write this number. This would be your D spot. So on your data table, this would be the number that you would put right here. What was that distance for the D spot for red 3? So that goes there. Then when we go back, now we need the D solvent. So you went from the bottom all the way up. So now you need this number. What was this number? So you want to write that one down. in your D solvent. Then you're gonna do D spot divided by D solvent and put it here, okay? So now we're just gonna stay on our chromatograph and so that you can see it. So now we're gonna move to R40. Okay, so I'll move it a little bit further away so that you can for sure see the dye there. So here's the dye. So if it's at the top, it went up to here. So now write your D spot based on if you're doing it in the middle or the top. Okay, now let's do the D solvent. Remember, you can always pause these videos. If we're going too fast, just pause it right quick so that you can write these down. All right, let's move to the B. So B1. Sometimes they move a little bit to the left or the right, but as long as we're staying on the line, that's all that matters. So I'm lined up. So here's your blue spot, your B1. So measure that D spot. And then go ahead and measure your D solvent. Okay, let's go to Y5. Okay, let me slide it over a little bit. Okay, so here's our Y5. So based on what you can see, measure either from the middle or the top. And then do your D solvent for your Y5. All right, now we're gonna slide down over here to Y6. So here's your Y6. The top, it's a little harder for you to see, is probably about right here if you're doing the top. So get your Y6 and then do your D solvent. All right, next is our G3. Okay. So here's your G3. And then your solvent, your distance for your solvent. All right, next is the mix. So you know what two we used. We used B1 and Y6, okay? So first let's do the Y6. So here's our Y6. So go ahead and measure that D spot. And then measure your solvent, your D solvent. Okay. Now we're gonna measure the blue, your B1, and your D solvent should be the same. Because it's in the mix, your D solvent for both of the mixes should be the same answer, but your two D spots are gonna be different. And you're gonna compare them to the ones that we used before in the mix. All right, unknown, we got 3 of them in the B3. Hold on, let me pick up my ruler. It's stuck on my staple. This one's a little hard to see, okay? So I'm gonna help you out a little bit here. Get it lined up. All right, so down here, you've got your first color, okay? So you can compare that over there to the other colors. So go ahead and write down your D spot for this guy. I would say the top is probably about here. Okay, your next color is around here. So probably about there. So you can measure that one. Okay. And then your next color stops about right here. It's a little trickier to see, but about right here. A little harder to see on the camera. And then here's your D solvent. And remember, the D solvent's gonna be the same for all 3 of the spots that's in your unknown B. All right, last one. Unknown F. Okay, let me get it lined up for us. Gotta kind of set it on top of my staple here. All right, this one's a lot easier. It's a lot more clear. So here's our first one. So you can get the measurement for that D spot. Here's the other color. It's nice and big, but I'd say the top is about here. And then here's our last color. It goes all the way almost to the very top of our solvent front. Okay. And then remember, here's your solvent front, and it's going to be the same for all three of your unknowns. So at this point, this was for the salt. You should have all of this first column, your D spot, and all of your second column, your D solvent. So now you could do the math for your RF values. And before we end this video, I want to show you, we've done all of that for the salt. I want to show you how far the isopropyl alcohol has gone, just so you can see how long some of these take. Okay? So the isopropyl alcohol is about to the height of where my finger is. Okay? And so this guy is much slower than the salt solution is. Okay? So in the next video, we'll process the, let me turn it for you so you can see it. There you go. You can see all of our spots. Okay, so in the next video, we'll process our isopropyl alcohol.